Hello student, how are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the SN1 aromatic means aromatic nucleophilic substitution unimolecular reaction, as well as we have discussed the elimination addition reaction via benzene intermediate. What type of the substrate and the reagent at what condition they are showing, that type of the reaction that we have learned with the help of suitable example. So what we are going to discuss today here, look at on the board, there is a existence of arynes. Existence of arynes means formation of the benzene is nothing but as aryne formation. How the intermediates are formed with the help of some of the example we have seen, and as well as we have learned what type of the structure of that benzene or the aryne intermediate had, how it can accommodate extra 2 electron on it, and what could be the structure or the resonating structure, and how what kind of the product it produce, everything that we have seen. So now the existence, whether that aryne intermediate or the benzene intermediate really formed or not, how do you prove it, how do you show it? There are certain examples or that prove the existence of aryne intermediate or benzene intermediate. Let us see the first proof for the existence of that benzene intermediate or aryne intermediate. Remember, aryne is nothing but as a substituted aromatic compound containing as a triple bond is termed as aryne, and benzene means what? Only simply benzene, and that containing as a carbon-carbon triple bond, and which is known as a benzene. So don't get confused between benzene and the aryne, one and the same thing. Suppose as only as a chlorobenzene treated with sodium amide in presence of liquid ammonia at -33 degrees centigrade produce or yield the benzene intermediate, which is a symmetrical, and then the amide group attack either any side producing as a single product, means only as aniline formation. But if you have a substituted chlorobenzene, but remember at ortho position there should be as a hydrogen atom, and then that type of the substrate produce as a benzene or the which is called as aryne intermediate. In a previous case we have taken as a starting material is a chloromethyl benzene, where the two substituents are there, but the methyl group and chlorine group, they are para to each other, and when they form as a intermediate, that type of the intermediate we can call it as a aryne intermediate, remember. And when only as a simple chlorine undergoes as a elimination addition reaction via benzene intermediate, there only as a benzene is there. Are you getting my point that benzene and the aryl is nothing but as a same thing? Aryne means substituted benzene, and that benzene means only as a simple benzene. But there when there is a halide groups are present, monohalide, if you treat with the sodium amide producing as a benzene intermediate and the substituted chlorobenzene, suppose as a benzene halide group along with that some other substituent like as a methyl, ethyl or other thing, that type of the compound are called as a arine intermediate. So that is it. Now the first proof, when that arine or what we can call it as a arine or the benzene treated with furan, furan gives the famous reaction which is known as a Diels-Alder reaction, and which is catalyzed on acid catalyzed produce the alpha naphthol is it is one of the proof for the existence of the benzene intermediate, because benzene cannot undergo as a Diels-Alder reaction. Only the benzene it can undergo as a Diels-Alder reaction with the furan producing as an intermediate. Further it is catalyzed with that acid and gives the gives the alpha naphthol. So that is one of the proof or the evidence for the existence of arine intermediate. Now as we know that how the benzenes are obtained, as we know that the structure of benzene. So let me draw here, this is a triple bond. So this type of the thing is called as a benzene, right? This is a, we are finding as a existence of arines. Now this benzene, or we can call it as arine, that will be treated with furan. Simply as we know that the structure of furan is this one. This is a heterocyclic aromatic compound. The name of this compound is a furan, which we have learned in your previous classes. I think in T.Y.B.Sc you have already learned this furan. Furan is a heterocyclic aromatic compound. And now I am, for the sake of convenience, I am writing that furan in this way. Here the furan I am writing here, and that O I am writing specifically like this, that furan. And now as we know that the Diels-Alder reaction, Diels-Alder reaction, and as we know that for Diels-Alder reaction there will be at MSc level you are going to learn, this is one of the famous reaction which there a Diels-Alder reaction takes place between the 4+2. 4+2 means one is a diene and second one is a dienophile, and diene which containing as electron donating group and dienophile which has an electron withdrawing group, then there will be a reactivity of that reaction, or that reaction takes place in a smooth way or in a faster rate. So that is a Diels-Alder reaction at a room temperature taking place. And because this is Diels-Alder reaction, why it is important? Because the resulting compound we are getting in 100%, and that's why this is a one kind of the addition reaction, and this reaction is known as a Diels-Alder reaction. In this case it is act as a electrophile and it is act as a nucleophile. This is a diene and this is a dienophile. Now the cyclic reaction, it is a electrocyclic reaction, or what we can call a pericyclic reaction. It is pericyclic, there is a formation of the transition state. So everything, how it is a clockwise, rotatory, anti-clockwise manner. So everything that we are going to learn in MSc. But here just remember, Diels-Alder reaction are taking place like this. This is a 2 pi electron, here you consider, and here is 4 pi electron. It is a diene and it is a dienophile. How this double bond is attacking on that, this double bond shifted from here to here. The electrocyclic, pericyclic means what? The electron are revolving in a cyclic manner, and that's why it is known as a pericyclic reaction. Look at here, this shifted from here, this shift from here, and this is going to attach over there, and you are going to get the formation of the product, this one. Now this double bond and this double bond remains as it is, but here this double bond, there is now here what is happening over there, one double bond is vanished, and we are going to get as a formation of the 2 sigma bonds are there, and then you are going to get over here. So you can write this structure this way, and now here is this oxygen atom more. 6-membered transition state is formed, and as we know that 6-membered transition states are highly what we can call it as a important one or highly stable one when it is treated with H plus. Then what is going to happen over there? Now look at here. Now this double bond shifted from here to here, and this bond is shifted from, means broken and formed over there like this. And what is going to happen over there? So that we are going to get the product here like this. This double bond, this is as it is, and here we are going to get, here is this double bond shifted from here to here, and now the double bond over here, and here we are, this double bond when shifted from here to here, what we are going to get over there? So here is a positive charge over there, positive charge now produced over there, but it is in the form of something is missing, that double bond over there, double bond, still there is a hydrogen atom, we can call it over there. There is a one of the hydrogen atom, 1 2 3 4 loss, that hydrogen atom, and now double bond. So there is a formation of double bond, and let me write how this double bond goes over there, and this double bond shifted not over here. Here is a one of the now this hydrogen atom comes over there, double bond over there, and this double bond, and this is nothing but as alpha naphthol. So this type of the things are happening over there. This double bond over there, and this hydrogen atom form as a double bond over there, and this double bond shifted over there, and we are going to get, here is a alpha. So this lone pair prism over there attacking over there, and we are getting this type of the alpha naphthol. So this is the one of the evidence or the proof for the existence of this arrahyne formation, that is a Diels-Alder reaction. How Diels-Alder reaction takes place over there, that is shown here nicely, and we are getting the final product or the end product is nothing but as a alpha naphthol over here. Now let us look at as a second evidence. First one we have seen, first proof we have seen as the Diels-Alder reaction, and second one that when this benzene is react with another benzene, and there is a formation of stable, means second proof is a dimerization takes place over there, and that is the second proof of existence of benzene intermediate over there. How dimerization takes place, and we are going to get as a formation of biphenyline, you can call it as biphenyline over here. Now let us look at, again they are showing 2 pi plus 2 pi, this is a third one, another one, that is again another benzene, one benzene react with another benzene at what we can call it as a self-condensation reaction takes place over there. Self-condensation reaction takes place over there. How? There is a 2 pi plus 2 pi electron cycloaddition reaction takes place over there. this double bond form here, and this is attacking over there, cycloaddition reaction 2 pi plus. In a previous Diels-Alder reaction, that is also as a cycloaddition reaction, but there is a 4 plus 2 pi electron, and here is a 2 pi electron, and we are going to get the formation of the biphenyl like this. This is a biphenyl formation takes place over there, and we are going to get, this is a biphenyl structure, biphenylene structure, biphenylene. So this is the second proof for the existence of benzene intermediate. Now is the third one is a mass spectroscopy. Third one is a third proof for the existence of mass spectroscopy, mass spectrometry, or mass spectroscopy, or what we can call it as a mass spectroscopy, mass spectroscopy. What do you mean by the mass spectroscopy? Mass spectroscopy, when you are going to go for the MSc, then you will study that one, mass spectroscopy. It is one of the modern technique for the elucidation of the structure of the unknown structure of the organic compound. So similar to as a UV, IR, NMR, mass spectroscopy, these are the technique, modern technique for the determination of the structure of the organic compound, those. And therefore in a mass spectroscopy, how when that what we can call it as the anthranylic acid is undergoes the fragmentation, and that produce the prominent peak at 28, 44 and 76 and 150 prominent peak in a mass spectrometry, when that anthranylic acid, means that what we can call it anthranylic acid, diazotized anthranylic acid, means suppose the starting compound is this one. Let us see here the compound which is written over here. They can form as a intermediate here, N triple bond N. Here is a positive charge. Anthranylic acid, as we know that O minus double bond O. Anthranylic acid means para anthranylic acid, you might be knowing as a structure of anthranylic acid is this one, C double bond O, OH and the NH. Or para amino benzoic acid is called as the anthranylic acid. This one is a anthranylic acid, and anthranylic acid when treated with the diazotized reagent, that form as a that type of the nitronium ion, and when there is a removal of this carbon dioxide over there, and it can form as a triene, and the driving force behind it, there is a elimination of this one nitrogen atom, as well as what we can get as a benzene intermediate over here, plus then N2 and plus carbon dioxide CO2. So this type of the product we are getting. Now the prominent peak observed in this mass spectroscopy are, one is I think 28, then 44, then 76 and 152 are there. These are the prominent peak observed in a mass spectrophotometer when you take this one. Now if you count the nitrogen atom, we know that one atom mass is 14 plus 14 is equal to 28, right? So this peak is there due to the presence of M upon Z. These are the values of M upon Z values. M upon E value means what? Mass to charge ratio. This is called as a fragment peaks, prominent peaks. And now if you look at here, carbon dioxide, carbon is a 12, oxygen is a 16 into 2 is a 32. So 32, if you add this, you will get 44. This is the 44th peak also observed there. Now if you remember here, 1 2 3 4 5 6 carbon atom, there are 6 carbon atom, so 12 into 6 is equal to it is equal to but 72 is there, due to the 12 into 6 is equal to 72. And how many hydrogen atom? 1 2 3 and 4 hydrogen atoms are there, so 1 into 4 is equal to 4, so total is a 76. So this is a peak due to the benzene, that proves the benzene intermediate over there. And when these benzenes are there, they get dimerized. So 76 into 2 is equal to 152. That is a diphenyl, as we know that. This type of the peaks are this type, not this one. The diphenyl, just now we have seen it exists. So they get self condensation, and we are going to get over there this type of the product, right? So this is the product we are getting, and this is m upon z value is found to be 152 mass unit, right? So these are the, by using as a mass spectrometry, we can show existence of the arine intermediate. And now the third one, when the benzotriene, what we can call it as a 1-amino benzotriazole. So fourth one, let us see here proof of existence of that mass spectrophotometry just now is. And fourth one, when 1-amino benzotriazole 1-amino benzotriol, when this benzotriazole 1-amino benzotriazole, when treated with lead tetraacetate, produces the benzene intermediate. And now as we know that the structure of 1-amino benzotriazole, so the structure of this is this one. Let me draw the structure here. This is the benzene, then here is a nitrogen atom, and then I think there is a 3-membered ring here, one more nitrogen atom here, then double bond N, we can write here is a nitrogen atom, triazole with 3 nitrogen atoms are there here, and NH2. And this benzotriazole, the name of this compound is a 1 2 3 like this. So at one position amino groups are there, therefore 1-amino benzo means that benzonide system is there. Triazole means 3 nitrogen atom in the same ring, so this is a 5-membered ring, and therefore, and this when it is treated with lead tetraacetate OAC4, what is happening there? Here we are going to get the formation of the product will be this one, then N, then double bond N, we can write here N, and N is a electron deficient in nature now, and it will be heated. What it gives, it produce this type, the nitrogen 3 triple bonds are there here like this, and this forming as a double bond over there, and this form as a triple bond. So in this way, what, there is a triple bond, this nitrogen has a triple bond, and therefore the end of the product formation, this shows there is a triple bond form, and there is a 2 NO2 groups are evolved here, 2 nitrogen atoms are there. So in this way we have proved there will be the formation of this type of the benzene intermediate. These are the 4 evidences which prove the existence of the what we can call it as a existence of benzene intermediate. So I think the last point remaining in this chapter is SrN1 mechanism, radical nucleophilic aromatic substitution reaction, and that point we are going to discuss over here, SrN1 mechanism. And I think that point we will see. I think these are the what we can call it as existence of proof for the arine intermediate. And now when we what we have discussed so far is important to remember as a benzene intermediate or the arine intermediate, how it is proved. There are the 4 different ways to prove the existence of the benzene intermediate. When the benzene intermediate is formed, when the aryl halides that is treated with sodium amide, particularly in liquid ammonia in presence of at minus 33 degrees centigrade, then and then there is a formation of the benzene intermediate, and that benzene intermediate proved on the basis of, there are the 4 different examples are given that shows the existence of the benzene intermediate. Number 1, that benzene is treated with that furan produces Diels-Alder reaction under acid catalyst produce the alpha naphthol, that proved that there is a formation of the benzene intermediate, right? And second example, that benzene itself undergoes as a self condensation reaction and produce the biphenyl. So that is the second evidence for the what we can call it that shows the existence of arine intermediate or the benzene intermediate. And third example we have seen, third one is according to as a mass spectroscopy. Mass spectroscopy, one of the modern technique for the elucidation or for structure determination of the organic compound. Those are unknown organic compound we can easily find out by collecting all the information about that. Mass spectroscopy shows that the molecular peak in the mass spectrum, and there is a fragmentation always takes place of that molecule, and they give the prominent peak in the mass spectroscopy. By collecting the information about that peak, we can easily arrive at the correct structure of the organic compound. So similarly, that benzene shows some of the prominent peak, that 28, 44, 76 and 152. So 22 clearly indicate that there is a loss of nitrogen atom. Nitrogen molecule, N2 molecule loss, that clearly indicate the peak due to the that one. And then again neutral molecule is loss from that anthranylic acid, which is carbon dioxide, which is also as a neutral molecule, that is not detected, but loss of that clearly indicate due to the 44 molecular weight of that compound. That is another prominent peak over there. And another one, what is that? I think 76 due to that clearly shows the existence of benzene intermediate. The peak at 76 is detected by the loss of benzene intermediate. And another prominent peak is appear around 152, and that is due to nothing but as a dimerization. When takes place, if you determine or if you measure, it is found to be 76 into 2 is equal to 152. So that is another example. And now last one, what is that? The 1-amino benzotriazole, when treated with lead tetraacetate, and as we know that lead tetraacetate is OAC, is nothing but as a acetyl group, and this is a oxidizing reagent which oxidize that amino group into that nitrine type of the formation over there, and when it is heated it produce loss of the nitrogen and form as a intermediate. So these are the fourth evidences that prove the existence of benzyne intermediate. I think with this, let us stop today here. Remaining last point of this semester, we can call it, we will see tomorrow. Let us stop today here. Thank you. Have a nice day.